Hello students, today we will discuss some previous year questions, and I'm starting with this year's ICSE paper, that is ICSE 2020. The first question which was asked this year was a MCQ, that is multiple choice question, and the question was the compound with low melting point is. Now, there were four options. Sodium chloride, the chemical formula which is NaCl. Second option was calcium chloride, which is CaCl2. Third, we have potassium chloride, which is KCl. And fourth, we have carbon tetrachloride, which is CCl4. Now students, though these chemical formula of these compounds are not given, now the compound with low melting point is. Now students, see, NaCl is an ionic compound, calcium chloride is also ionic compound, potassium chloride is also ionic compound, and generally ionic compounds have high melting and boiling points. Now last option, carbon tetrachloride, is a covalent compound, and also we know that it is symmetrical, so it is non-polar covalent compound, and therefore the intermolecular forces in CCl4 are very weak, and therefore carbon tetrachloride has the lowest melting point. So correct option is option D. Now the next question was, now give one word for the following statement. So the question was, आपको एक statement दिया है and you have to give one word for this statement. Now the statement was, the chemical bond formed by a shared pair of electrons and each atom contributes one electron to the pair. So students, this is a basic definition of what? Covalent bond. So the answer was covalent bond. So this was very easy question. Now the next question which was asked was that students were required to fill up a blank. Now the statement is, the polar covalent compound in gaseous state that does not conduct electricity is. Students, three compounds were given, and we have to select one which is polar covalent compound and does not conduct electricity in gaseous state. So students, let me tell you, CCl4 is a non-polar compound being symmetrical. Methane is also non-polar compound. Ammonia, we have learned that ammonia is a polar covalent compound, and only polar covalent compound, they conduct electricity in aqueous solution. So the correct answer is ammonia. Students, the next question is, the following table represents the elements and their atomic number. So elements P, Q and R were given, and their atomic numbers were given 13, 7 and 10 respectively, and it was asked that name the element which forms an ionic compound with chlorine. Now students, see, this element 13 has configuration 2, 8 and 3. This element has configuration 2 and 5, and this has configuration 2, 8. Now the element R has 8 electrons in the valence shell, so element R cannot form any chemical bond. Now we are left with P and Q. Now Q has 5 electrons in the valence shell, which means it is a non-metals, and chlorine is also a non-metal, and non-metal cannot combine with another non-metal through ionic bond. So therefore The correct answer was P. This element actually is aluminium, has 3 electrons in the valence shell. Aluminium we know is a metal, and metal combines with chlorine, that is a non-metal, to form an ionic compound, aluminium chloride. Now, the next question was, okay, it was very easy question. Draw electron dot diagram for the compounds. And the first compound was calcium oxide. Now, see students, in calcium oxide, the constituent elements are calcium and oxygen. Now, calcium we know has configuration 2, 8, 8, 2. That means calcium has 2 electrons in the valence shell, and oxygen has configuration 2, 6. So oxygen has 6 electrons in the valence shell. And now listen student, calcium oxide is a compound between metal and non-metal, and so electronegativity difference between these two elements is quite large. So obviously this compound is ionic, and we know that in ionic compound metal will lose electron. So calcium, in order to acquire noble gas configuration, will lose these 2 electrons, and whereas oxygen require 2 electrons to attain nearest noble gas configuration. So calcium will lose these electrons to oxygen, and thereby calcium acquires 2 positive and oxygen acquires 2 negative. So electron dot structure is this, and then these 2 ions attract each other to form an ionic compound, calcium oxide. So this is the electron dot structure. Now next we have chlorine molecule. Students, chlorine molecule is diatomic, Cl twice molecule. Now here the constituent atoms are chlorine, and chlorine we know has configuration 2, 8, 7. So there are 7 electrons in the valence shell, and these 2 chlorine atoms combine through covalent bonding. So second chlorine has again 7 electrons, so they share 1 electron pair, so as to have 8 electrons in the valence shell. So since there is 1 shared pair of electron, we can say that chlorine is covalently bonded to chlorine by a single covalent bond. Rest all other electrons are non-bonding, so they act as lone pair of electrons. So this is the electron dot structure of chlorine molecule. Next we have water molecule. Now students, water chemical formula is H2O. The central atom here is oxygen, and surrounding atoms are hydrogens. Hydrogen we know has 1 electron in the outermost shell. This hydrogen has 1. Oxygen where has how many? 6 electrons in the valence shell. Now, so oxygen will share 1 electron each with the surrounding hydrogens, so that hydrogens satisfy the duplet rule and oxygen satisfies the octet rule. So now you can see that each combining atom has attained the noble gas configuration. Now see, O to H, there is 1 shared pair, so H is bonded to oxygen by a single covalent bond. This H is also connected to oxygen through single covalent bond, and these 2 electrons, they are non-bonding. These 2 are also non-bonding, so we have 2 lone pairs of electrons. So this is the electron dot structure of water molecule. So water molecule has 2 lone pair of 2 lone pairs on oxygen. Dear students, now we will discuss ICSE 2019 questions from chemical bonding. The first question is, give appropriate term which is defined by the following statement. The statement is the covalent bond in which electrons are shared equally between the identical combining atoms. So now we have to identify the covalent bond in which electrons are shared equally by the identical combining atoms. So listen students, since combining atoms here are identical, so the electronegativity difference, say if I am taking X is covalently bonded to X, and since atoms are identical, they contribute equal number of electrons to the shared pair, and since atoms are identical, electronegativity difference between them is 0. So the answer is the covalent bond which is defined by the above statement is non-polar covalent compound. Non-polar covalent compound. So answer is no polar covalent compound. Now again, second question was to write electron dot diagram of first nitrogen molecule. So student, nitrogen molecule we know exists as N2. So here combining atoms are 2 nitrogens. But see, nitrogen we know has configuration 2, 5. So there are 5 electrons in the valence shell. So nitrogen has 5 electrons in the valence shell. Similarly, the second nitrogen has 5 electrons in the valence shell. So these are the 5 electrons. And now these nitrogen atoms share 3 electrons, so that each nitrogen has a complete octet. So this is the electron dot diagram of nitrogen, now which can simply also be written as like N. So we have 1, 2, 3 pairs. So this is triple covalent bond, and each nitrogen has 2 non-bonding electrons. So these electrons act as lone pairs. So this is the electron dot diagram of nitrogen molecule. Second is sodium chloride. Now sodium chloride is ionic compound. Sodium we know has configuration 281. Chlorine has configuration 287. Now sodium has 1 electron more than the nearest noble gas, and chlorine has 1 electron less than the nearest noble gas. So what happens is that chlorine gains an electron from sodium. So this is shown as sodium has 1 electron in the valence shell. Chlorine has 7 electrons, and sodium will give this electron to chlorine, and thereby sodium will acquire a unit positive. Chlorine gains an electron, so acquires a unit negative charge and has complete octet. And then these two ions, oppositely charged ions, sodium and chloride ions, they are held by strong electrostatic forces, which is called ionic bond. Next we have ammonium ion. Now students, how to write structure of ammonium ion, electron dot structure. So listen student, first we see how many electrons, or we find how many electrons each atom will have when it combines. Nitrogen will try to have 8, and hydrogen we know that follows duplet rule. So 4 hydrogens, they tend to have 2 electrons in the valence shell, and 1 positive means there is 1 less electron. So we have 8 plus 8 minus 1. So we have what? Total 15 electrons. Wait. So 8 plus 8, 16. So we have 15 electrons. Now valence electrons, nitrogen has 5. Hydrogens, they have 1. Since we have 4 hydrogens, so 5 plus 4, 9. Now difference between N and V will give us the electrons which are shared. So 15 minus 9, we have 6 electrons which are shared. Students, I have made a mistake here. Actually, we have to subtract this 1 electron from V, not N. So we have 8 electrons. Nitrogen will try to have 8. Hydrogens they will try to have. So this is not 15 but 16. V, we have 5 electrons, valence electrons of nitrogen. Hydrogens have 4. And now we'll subtract 1 because ammonium ion has 1 positive. So this is now 8. And difference of 16 and 8 is 8. So there are how many? 8 electrons which are shared. Now lone pairs of electrons we have to calculate, and we find lone pair of electrons V minus S. 8 minus 8, so 0. Now we'll distribute these shared and unshared pairs of electrons between the combining atoms. So students, now we have to arrange these shared and lone pair of electrons between the combining atoms. Here we take nitrogen as the central atom because hydrogen always occupies the terminal positions. Now see, how many electrons we have as shared? 8. And students, I have told you that first we distribute these electrons for single bond. That means a single pair. So now you can see we have consumed all the electrons. Now we do not have any lone pair, and all the atoms also have what? Hydrogens have complete duplet and nitrogen has a complete octet, and net charge is +1. So this is the electron dot structure of ammonium ion. Students, now we will discuss ICSE 2018 questions. The first question was, give one word or one phrase for the statement. The process of formation of ions from molecules which are not in ionic state. So student, answer to this question is the process of formation of ions from molecules which are not in ionic state. Now compound is not ionic, so obviously it is covalent, and we are assuming that it is polar covalent compound because it undergoes formation of ions. So it is HCl, say, in water undergoes ionization. So the answer for this is the process of formation of ions from molecules which are not in ionic state is ionization. So answer is ionization. So the one word for this process is ionization. Now second question was, give reason why ionic compounds have high melting point. So student, it is a very easy question. Ionic compounds have high melting points because in ionic compounds the constituent particles are ions, and these oppositely charged ions in an ionic compound are held together by strong electrostatic forces of attraction, and that is why they have high melting points. Now students, next question was to fill up the blank. Now ionic compounds do not conduct electricity in dash state, and there were two options, fused and solid. So listen students, in ionic compounds, since constituent particles in solid state are firmly held, they are not free to move, so they do not conduct electricity in solid state. So here the correct choice is solid state. though they may conduct electricity in fused state, because in fused state ionic compounds undergo dissociation into ions freely. Now we have fourth question from the same exam. What do you understand by lone pair of electrons? So student, lone pair of electrons are electrons which do not take part in bond formation. For example, student, in ammonia, look, nitrogen is covalently bonded to hydrogens and uses its one electron in covalent bond formation with hydrogens. So hydrogens, they also participate. But look, nitrogen has say one electron, second electron, third electron, and the two more electrons in its valence shell are, these are fourth and fifth. Now these are used up in bond formation, but this pair of electron is not used up by nitrogen in bond formation. So such pairs of electrons which are not taking part in bond formation, they are called lone pairs of electrons. So what do you mean by lone pairs of electron? We simply write the electron pairs which do not take part in bond formation. Now student, next is again a very important question. You have to draw electron dot diagram of hydronium ion, and again we will follow the same procedure which we have used for ammonium ion. Now in hydronium ion, students, first in noble gas configuration, hydrogens, they tend to have duplet, so 2 into 3, and oxygen will tend to have 8. So total noble gas configuration electrons 8 plus 6, we have 14. Now valence electrons, hydrogens, they have 1 electron in the valence shell, oxygen has 6, but here again 1 positive means we have to subtract 1 electron, so we have again 3 plus 6, 9, so we have 8 electrons, minus 1 is also there. Now shared electrons will be difference of N and V, so 14 minus 8, we have 6 electrons which are shared. And lone pair of electrons, now this is difference of V and S. V is 8, shared electrons we have 6, so difference is 2. Now we will distribute these electrons among hydrogen and oxygen atoms. Now central atom here is again oxygen, as hydrogen atoms always occupy terminal position. So we have how many? 6 electrons which are shared between these atoms. So these are first 2 electrons, we distribute them for single bonds first, and since we have already consumed all the electrons, now there are 2 lone pairs of electrons. Now where to place these 2 lone pair of electrons? Now hydrogen has 2 electrons, so hydrogens, they have attained the nearest helium-like configuration. Now you see oxygen has only 6 electrons, so require 2 more electrons, so obviously these 2 electrons, they are on oxygen. So this is the electron dot structure of hydronium ion, and see these 2 electrons are not participating in bond formation in hydronium ion, so this pair acts as lone pair. So in bond line notation, we may write hydronium ion in this manner. Thank you students, and now I expect you to practice more questions from ICSE exams. Thank you.